Okay, page 66, uniform motion with unknown rates. Example 5.21. A boat travels upstream for 60 miles in 3 hours and returns in 2 hours, traveling downstream in a local stream of water. What is the rate of the boat in still water and the rate of the current? So we want to set up our variables this way. So I'll let B equal rate of boat in still water, and let C equal rate of the current. Now if you think about what's happening here, you're kind of fighting the stream, so it's going to take you longer, but you're going the same distance. They're going 60 no matter what. But the current is kind of pushing it against you and slowing you down. Okay, so if you've ever boated, you know that's a problem. So, or even just like on a paddleboard or a kayak or something like that, you're slower that way. So it's going to take longer to go the same distance. So if I have my rate, so we have to kind of set this up as rate. How did I do it? I did against first, I think. So rate upstream, we're going against, so that's our system. Our first system equation is going to be B minus C is our rate upstream, but we actually want to just set up the whole situation, not just the rate. We're going to set up our time times our rate equals our distance of 60. So that's my equation 1. This is my rate up, because I have to subtract off whatever the current is pushing against me. And if you get it backwards, if you get these with the signs off, you'll just get a negative. So just notice that and you can, change it up. So then this is the downstream info equation. So we would have 2 hours, but this time my boat has the current working with me. So I'm going to add that on because I'm going to have a higher rate. That's also equal to 60. So now we can distribute and work with these, or we can actually, one way to do it is just to divide first. I could divide both sides by 3 on this one and get, that might be a nice route to go. That's not how I did it originally, but okay, that's my system. So I'm going to write this as B minus C equals 60 over 3. But 60 over 3, let's see, what I'm doing is taking the whole thing and dividing both sides by 3. And here I'm going to divide the whole thing by 2. So then I'll get B plus C equals 60 over 2. Well, if I calculate that out, now I can do a nice little system here. I can have B minus C equals 20 and B plus C equals 30, which makes it really nice because then look at this. I have a match on that already opposite coefficient, right? So I can use adding. Add those together. I end up getting 2B equals 50. And then I can divide both sides by 2, and I get my boat rate equals 25 miles per hour, which it's given in miles per hour. When your boat is really, you do knots, but that's okay. We'll ignore that part. Now we can also do the same thing here. We can just eliminate the other one, or we can pop this into either of our equations and figure it out, but I'm going to show you how to do it with the other variable. So if I wanted to eliminate the b's, I would have to multiply through by -1. So I would have to have negative b plus c equals -20. B plus C equals 30. And then the B's cancel out, right? Because I'm going to add these. I'll get 2C equals 10, -20 plus 30. Divide by 2, and I get C equals 5 miles per hour. So that's actually not bad. That's a really quick way to do it. There's a number of ways you could set this up, but I think solving by substitution might just be fine as well. You could, the key thing is you really want to do this piece. I did this one earlier and I actually just kind of distributed everything out and I got the same answers, but it wasn't very efficient. But you could go that way and you'll get the exact same answer if you're not comfortable with this division here. But that's a totally legit way to solve things out. If we have an expression, anytime if we had like 3 times x plus 1 equals 9, I can divide both sides by 3 because that's a quantity. It's a factor. I'm dividing factors with factors there. So I can do this. That's a legal thing to do. And then I just have to make sure I write my sentence, which it's not fitting here very well, but I'm going to squeeze it right here, that the boat rate is 25 miles per hour and current is 5 miles per hour. Alright, and that's it for that one. And again, we have our parts A, B, C, and D. Okay, so example 5.22, this one is Turkey the pigeon travels the same distance of 360 miles in 5 hours against the wind as he does traveling 4 hours with the wind in local skies. What is the rate of Turkey the pigeon in still air and rate of the wind? So it's the same setup as the boat problem, that you have a with the wind and against the wind. So try to do that on your own. Do this one as classwork, and then I'll write out all the pieces, and then I'll kind of use the laser pointer to just go through it quickly for you. Okay, so I'm going to stop here for a sec just to check in. So we have let x equal rate of Turkey in still air, y equal rate of wind. We want to set up an equation for against the wind. Our time times our rate. The rate against is, again, the rate of the Turkey in still air minus what the rate of the wind is because it's pushing against, equals our total distance of 360. With the wind, again, we have time times our of 4 times x plus y equals 360. Then I can simply divide out both sides by 5, which I wrote over here. X minus y equals 360 over 5, and x plus y equals 360 divided by 4. You can also think of this, you could jump right here because rate equals distance over time. So you actually don't even have to set up your equation like that. You could set it up immediately this way if you wanted, if you were okay with that. Now we're going to add and eliminate the y's, right? So we would have then 2x equals 162, divide both sides by 2, and we get x equals 81. We could just back sub that right up in here for y, x minus y equals 72, so we could do 81 minus y equals 72, and then we're just going to solve out for y, so we would have negative y equals 72 minus 81 gives us -9. So y equals 9. And then just, check to make sure that all works out. So that would be one way to do it. We also could do it as this, just manipulating the other equation. So then we would have -x plus y, I'm just multiplying through by -1, equals -72. X plus y equals 90. That one stays the same. And then add them together. And then we would eliminate the x's, and we would get 2y equals 18, and divide by 2, we also get 9, just like we did with the back summing. So the choice is yours. I do want you to get familiar with being able to eliminate both variables, eventually, but back summing usually works pretty well if you have whole number answers. Sometimes it does get actually messier and harder to work with when you end up like with one of them being a fraction, then you get a back sub into fractions or something. So I want you to realize that there is a couple of different ways to do that. And then my answer again would be the 81.9, and then I would just write Turkey is traveling. And remember, it's not really a turkey, it's pigeon. So it's traveling at 81 miles per hour. That's why a turkey would not go that fast. And the wind has rate of 9 miles per hour. Okay, so I hope you found that helpful. As you're working through your homework, if you have questions, let me know. If the electronic homework doesn't have enough videos and stuff, you can ask me to do one for you, or also I could write up a solution. Maybe you just want to see a similar example, and if there's not enough resources for those, I can put some additional things in the Canvas course as well for these types of problems, just so you have a good variety. So have a great day. Thanks for watching.